In this section of our lesson, we're going to start off by getting our player to be able to jump. And we have to set up some other things first in order to pull that off. First of all, we need to make it so that our player responds to gravity, our own custom version of gravity that we set up as an instance variable called GRV. We'll use that to pull the player down towards the floor. And we need to set things up so that our player will collide with that floor if they run into it. Okay? And that will work in a similar fashion to what we did with the horizontal collisions. So let me talk through the beginning of this to sort of explain what it is we're going to do. If you go into the region we worked on last time in collisions and movement, here's where we set up our horizontal collision. And here's where we're moving pixel by pixel toward the wall if we're close enough to a wall. And here's where we're just moving 4 pixels to the left or right if we're just doing a regular set of movement. Now imagine for a second that underneath here I'm going to say move vertically. And I update the position of our y coordinate equal to, we're going to add to our y position every step the value of, gravity. Okay, this isn't really what we're going to do ultimately, but let me show you this. So I'm going to take our current value of y and we're going to increment it by whatever we've saved in our gravity variable, this guy that we set up over here. Okay. Now if I come down into my room and take my player and move him way, way, way up in the air and hit play, assuming I've done this right, what we should see, I'll have to be really quick, is, here we go. You can see our player is very slowly dropping down frame by frame toward the floor at 0.34 pixels per step. So we can use our step event to update their vertical position. Obviously we want it to be a little faster than them. That's fine. We'll play with that here in just a minute. But imagine once this guy hits the floor right now, he's just going to cruise on right on through because he doesn't have any events or actions set up to respond to running into the wall. So I'll leave this here even though we're going to update it. So we want to do something similar to what we did here with the horizontal collisions and movement to detect when we were going left or right and running into a wall. And in fact, what we're going to do is so similar, I can actually copy this. And I'll come down below where we're updating our x coordinate and I'll just paste it in. Let's change this now to say vertical collisions and movement. And now we have to think carefully, what is it we want to check? Well, imagine that the player is falling, just like we saw a minute ago, with the force of gravity. They're falling toward the floor. So we want to check our current x position of the player. So left and right is just going to be where we're at. And we want to check y plus our vertical speed, whatever our vertical speed is. So that's the speed at which we're falling towards the floor. All right. And what are we looking to see if we're going to run into? We're checking to see if we're going to run into a wall object. Confusingly named because in this case we're using it as the floor. But it's essentially we're looking for an object below us that is of this name. Right? So if we are going to run into a wall object, in this case meaning we're going to run into the floor, just like we did on the horizontal movement, we're going to move ourselves bit by bit by bit up until we land right up against the floor. So we can say, wow, we are not touching our current position on the x, and then in terms of the y, we want to take y plus, and then what are we going to do? Well, one way to do this would just be to say y plus VSP, okay? But that's assuming that VSP is positive, and it's possible that our vertical speed could be negative. For example, if you jump while the player is moving up in the air, their vertical speed is going to be a negative number. So we don't want to do that. What we want to do instead is use this very clever use of the sine function again, and here we'll put VSP. Just like we did up in the horizontal one, what this will do is it will check what if the vertical speed is a positive number or a negative number. And if it's a positive number, it will return 1. If it's a negative number, it will turn -1. So this allows us to, if we are close enough to the floor or to a platform above our head, to collide with it in the next step, then we're going to move 1 pixel closer to the floor or to the platform right above our head, over and over and over, pixel by pixel by pixel, up until the moment that we actually then run into that. And once we run into it, then while we're in this while, we got to move pixel by pixel. So let's do that. All right. We'll update our y coordinate to adding to it 1 or subtracting from it -1. And then once we've come up against the floor below us or directly above us, then we'll set our vertical speed equal to 0. All right. Now, when I was demonstrating the regular vertical move, here's if we're close to the floor or close to a platform above our head, we move pixel by pixel. But if we want to move just sort of in a regular step-by-step, so let's say you're moving your player on a platform and you move them right off the end of the platform, how do we take care of that vertical movement if there's no floor right below them? Well, in our example, I updated it using gravity, and you saw how slow that was, and so we don't really want to do that. What we want to do is update our y to be whatever the value of VSP is. Now, when I update it to when I update it to be, to add to it whatever the value of VSP is, we've now eliminated the use of gravity again, which is a little confusing, right? So let's go all the way back up here where we calculate movement. And here we're updating HSP to be whatever the value is of move times the walking speed. And remember, move is going to be 1, 0, or -1. So while we're here, there's another thing we want to do every single step, no matter what else happens, and that is update our vertical speed. And what we will update it to is whatever our current vertical speed is, plus the value of gravity, that 0.34 in our case. Okay. And remember, this is the long way of writing this out. You can also just say plus equals gravity, and that's essentially the same thing. Here's a comment. I could say VSP equals the current value of VSP plus the value of gravity. Okay, same thing. All right, so let's take a look and see if we've screwed this up, which we might have, and we'll fix it if we've made some errors. Now our guy falls down. Now he's a lot quicker, and boom, when he hits the ground, now he nicely stops and doesn't fall through the ground. Okay, very cool. So this is one that happens every frame regardless. Gravity is pulling on our player by adding the value of gravity to the current value of the vertical speed. Then down here in collisions and events, we check for collisions, and if we're going to run into the floor or a platform directly above our head, we also, in addition, increment the value of our y 1 by 1 by 1 up until we hit that floor or platform above our head, and then we set VSP equals to 0. Okay, so we now have implemented our own custom version of gravity that's pulling on our player constantly, and we've implemented vertical collisions so that when they are pulled down and touch the floor, they won't fall through the floor. With those two pieces in place, we can finally return to the idea of allowing our player to jump. To allow our player to jump, we need to give them a way to indicate that they want the player to jump. So we'll go all the way back up to our player input region up here, and let's call it, let's give us a new custom instance variable that we will call key jump. And we're going to set key jump equal to, it's very similar to what we did before, keyboard check but I'm going to do this one slightly differently because I don't want them to just be able to hold down a jump key and have the player just jump, 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 jump. So I'm going to use keyboard check press, which means they have to press a jump key, release, and then press it again if they want them to jump again. And for this, we'll give them a couple choices, just like we did with our left and right keys. So we'll use the built-in ORD function to pass in a specific key that we want to use for jumping. You can use whatever you like. Initially I used the space bar, and then I ended up using the W key, so I'm going to stick with that again here. And as with our left and right keys, I want to give some options. So I'm going to check if they press the W key or if they have pressed, if I can type correctly, check, we'll use pressed, and we'll use the up key as well. So it works the same way. If the player is pressing the W key or if they're pressing the up key, this key jump will contain the value 1. If they're not pressing either of these, then this will contain the value of 0. So far it works just like our left and right keys. Given that it's going to work in a similar way to our left and right keys, let's come out of our collisions and movement and come into our calculating movement section. And in our calculating movement section, let's see. Well, do I want to calculate this here? Sorry, I'm pondering here for a moment. No, let's logically move this down into our collisions and movement. So here we're doing sort of standard horizontal collisions with walls. Here we're doing standard vertical collisions if they land on the floor. So let's make a special case here in collisions and movement for jumping. All right. And what we want to do is we want to check for a couple of things. We're going to make some rules for the player to be able to jump. And the main rule, is that they have to be standing on the ground in order to jump. We're not going to let them jump if they're already up in the air. You will see platformer games that do allow them to jump if they are in the air. It's a double jump, and we might implement that later, but we'll stick with the basic version for now. So we're going to check if, and this is going to look very familiar, if place meeting their current X position, their Y position plus 1, meaning we want to look 1 pixel below where we're standing at the moment. If that's true, that basically means they're standing on the ground, right? Because 1 pixel below them is one of these confusingly named wall objects. So by doing this check, we can determine if they are in fact standing on the ground. But that's not the only thing we want to check to allow them to jump. What's the other thing we need to check? Well, we need to know if they've pressed the jump key. Alright, let me get rid of this here. And we'll put this here. That should be right. Good. Alright, so what we're doing is we're saying if they're on the ground and they've pressed the jump key. So how does this work, just saying key jump? Well, remember that if they press the jump key, then this is going to contain the value of 1. And the value of 1 is just another way of saying true. So if this is 1, that means key jump is true. It means they've pressed the key jump. If this is 0, it means they haven't pressed the key jump, and then nothing in here will happen, because both of these need to be true in order for us to run the code that's inside these curly braces. And what is the thing we want to run in here? We just want to update the vertical speed. And what do we want to update it to? Well, we want to update it to indicate that the player should move upward in the air. So we want to set it to a negative number. You can set this to be whatever you like. I'm setting mine to -7. This is not beautiful coding because I'm putting in a number that has no meaning here. So you could create an instance variable called, like, I don't know, jump height or something like that. But for now, we'll just do this. Okay. So if they're on the ground and they hit the jump key, then we're going to update our vertical speed to be 7. Now you can see after all of that happens, we update the Y position by adding to it whatever the value of VSP is. Okay. So if they press the jump key, that means their Y coordinate should be less 7 pixels. So let me try this. So I press this, I'm pressing the up key, and you can see I press it, he moves up, and then gravity is working on him every single step of the game, so it's always pulling on him. So by implementing that gravity and calling it every step, even when I jump, he drops back down onto the floor. So ooh, now we're really getting somewhere. Look at there, I can jump up over here, I can come over here, fall down into this spot, and all of the left and right movement is doing exactly what we want it to do. Cool. So what's next? Now that our player can move left and right, they can jump, gravity is pulling them on them constantly inside the game, it would be nice if they would show an appropriate direction. Like when we're moving left, I want to have my guy face left, and moving right, face right. And when they jump, it would be nice to have something other than this same idle animation showing. So let's set that up in this section. To make our player sprite animate correctly and face the right direction, whether it's standing, walking, jumping, or landing, or shooting, we need to bring in some more sprites. Now, I've already started to do this here because we don't need to do it in the video, you've done it already, but you'll want to create a new sprite for each of the various animations that we have for the player in our resources folder that go with the project that you can find on the Blackboard site. I've already we brought in the player one, we're using it already. I brought in one called S-Player S, which is going to be the animation when the player is walking and shooting his weapon, and another one called S-Player R, which is when the player is sort of running or walking. And there are a couple other ones that you want to bring in. I'm not going to walk through all of them, of course, but I want to show you briefly. So create a sprite and choose import and hunt down your resources folder that goes with this project. Here's mine, and go into the sprites folder, and then here are all these sprites that are available for the project. We've already used the S-Player strip 8, and then I, behind the scenes, brought in the S-Player R strip 6 and the S-Player S strip 6. So there are a couple more left. There's still the S-Player A, which is the one we're going to use for jumping and landing, and S-Player SS, which we're going to use for just standing still and shooting. Alright, so let's bring in the S-Player A just to remind you how this works. It's named as strip 2, so it's automatically going to divide it up into 2 cells when we bring it in. The main thing you'll want to remember as you're bringing in each of these player sprites is to reset the origin point to be middle center. You don't need to play with the collision mask on any of the other sprites, and I'll talk about why that is in just a minute. If you remember back on the original sprite that we worked with, we modified the collision mask so that it doesn't cover the arms and it doesn't cover part of the head. Well, we don't need to do that for the other ones, so let me show you that. So bring in all of your sprites and make sure to do what I didn't do, which is to name them appropriately. You can name them whatever you want, but I'm following the name of the image itself that I'm bringing in. Okay. And then return to the video once you've brought all those player sprites in and got them set up with the origin point to be middle center. Alright, make sure you've got them all in there. S-Player we had before, S-Player S, S-Player R, S-Player A, and S-Player SS. And now let's make use of these by going back into our player object and back into our giant and ever-growing step event. And let's now work to swap in the appropriate animation depending on which way our character is moving. All right, so to do this, let's go ahead and create another new region. So come down below the last one that you created. And this region will be for animations. And we'll put in a end region as well. And come up into it. All right, so what do we want to do first? Well, we're going to do a collection of if statements that we'll use to determine which direction the player is going, if they're moving or not, or if they are jumping in the air or not. And then depending on all of that, then we'll show the correct image. All right. So, and we're going to start with well, not a basic version, but we're going to start with a version based on the actions that we've already built into the game up to this point, and then we'll modify it later once we introduce the ability to shoot. Okay, let's start with imagine that we are jumping. Okay, so we can come into here and we'll start off by saying if not place meeting, and if we're talking about jumping, remember the way we determined if we were able to jump is to see if there was a wall object 1 pixel below the player. Remember that? And before then we said if place meeting x y+1 object wall, that meant we were on the ground and we were able to jump. But what if we're not on the ground? We would say if not place meeting, and then look directly below us to see if there's something there or not. Well, if there isn't a wall object directly below us, that means that our player is in the air. All right? And if the player is in the air, we want to switch from the regular sprite that we're using for our player into Sprite A, which is a 2-frame image. The first frame is the one we're going to use when the player is going up and is in the air, and the second frame is the picture that we're going to use when the player is in the air but is moving back down toward the ground. So to make that work, we're checking if we're in the air first, then we'll change the sprite using Sprite Index. We've done this before. We did it in the Evil Clutches game when we were switching between the regular player and the frozen version of the player. We switched the Sprite Index. It's just a way of switching from one sprite associated with an object to another sprite. And we'll set that equal to S player A. So we've now switched. Now we need to tell GameMaker which picture within that S player A sprite we want to use, the first frame or the second frame, or since we're doing programming style, the first frame is actually frame 0 and the second frame is frame 1, just to make things confusing. So we'll say, okay, we want to use that sprite, and then with all of the other sprites we're using in this game up to this point, they're all animated, and when you are using a sprite that's animated, if you don't say not to, GameMaker will automatically animate that sprite. It'll rotate through each of the frames in the image. We don't want that to happen in this case. If the player's jumping up into the air, it's not like an animated sprite in that 2-frame jumping image, right? We just want to show one of them if they're going up, and the other one if they're going down. So to stop the animation from playing, we can use another built-in function called, or I guess I should say property, called image speed. And we're going to set the image speed equal to 0, which means it will not animate. Now how do we tell which of the 2 frames to play? Well, we want to check if we're moving up or if we're moving down. So we're going to use our new friend sine, this built-in function that you remember will return a 1 if a value that we pass it is positive, and a -1 if a value we pass it is negative. And we're going to check what is the sine of our vertical speed. And the way this is going to work is this. If the sine of our vertical speed is positive, that will return a 1. That means we're going up in the air. So if we say if sine of vertical speed is greater than 1, that means we are currently moving upward towards the top of the screen. And if that's the case, then we will set the image index. This is how we can select which frame in our sprite we want to choose, equal to 1, which is the second image. Right? Even as I'm saying that, I'm thinking, that doesn't sound right. So if the sine of our vertical speed is positive, that's 1. That means the vertical speed is positive, which means we're moving down screen. Remember that the y coordinates get larger as you go down. So if you're moving downward, it'll be a positive number. And the y coordinates get smaller if you're moving up, which means the vertical speed would have to be a negative number. So if the vertical speed is a positive number, that means we're moving down screen. And so we want to show the second frame in our image, which is the image for moving downwards. Else, image index equals 0. So if we're moving down screen, we'll use the second frame, which is frame 1. Otherwise, we'll use the first frame, which is frame 0. Well, that's confusing. And now you'll notice that I've written this if statement using just a single line, and that will work here because we're only performing one action within the if and one action within the else. If you want, you can use the squiggly braces. It will work exactly the same way, but this is just to save a little space. Okay? So this will make things work for jumping. We've got to do a bunch more stuff, but let's see what happens. Some stuff will go wrong, of course. With how we've got this set up right now, it should work so that when we jump up in the air, we get the up one, and when we're coming down, we get the down one. But of course, once we switch into the sprite for jumping up or down, we never change back because we haven't set that up. So now we are we're forever in the air, but falling towards the ground image. So let's continue on. So that'll take care of jumping. And in fact, maybe I'll put a little note here. Jumping sprites. Well, we need to do more than that, though. We also want to check what happens if they are not in the air. That's what this whole thing is doing. Well, we can do an else. And then we'll say not in the air. Okay. So if they're not in the air, we need to show some different sprites, right? We need to be able to show our regular player. And if our regular player, we have to be kind of careful here. There are different versions of the regular player animation, the one that is standing on the ground. One version is the idle animation. That's what we've been using in this project up to this point. So if the player is just standing, it is not moving, then we want to show the idle animation. If the player is moving, then we want to show the running or walking, however you want to think about it, the moving image, where they're moving left or they're moving right. So how do we determine that? Well, we can say if HSP is equal to 0, and remember, use these double equal signs if you are checking to see if something is equal, and you use a single equal sign if you're setting the value of something. So if we want to check if HSP is 0, we use double. If their horizontal speed is 0, well, that means that they're not moving. So we can use the idle animation. So we'll say sprite index equals s player, which is our idle animation sprite. Well, what if they are moving? Well, then that's going to be one of these else statements. So if the horizontal speed is not 0, it means they must be moving, so we need to change the sprite index yet again. And now we can change it to S player R, which is the one where they are moving along. Okay? Now there's a problem here. I wonder if you can see it. When we were setting up our jumping sprite, one of the things we did was we set the image speed to 0 because we didn't want our jumping sprite to automatically animate. So this, once we've set this to 0 inside this if statement, when we come down and land again on the ground, we will continue to have the sprite, the image speed be 0. So even though we want our idle animation or our walking/running animation to animate, it won't. So we need to take care of that as well. So let's go right down into the beginning of this else statement where we're checking and making things happen when we're on the ground. And here we'll say image speed equals 1. So that will do a full 100% speed animation. All right, let's see if we're getting a little closer. Of course, we're still not there yet. There are going to be other things that we need to do, but let's see what we've got so far. All right, here is our player standing on the ground, and he's doing his idle animation. He switches to a walking animation when I press the right arrow. He switches to a walking animation when I go left, but of course he's facing the wrong direction, so we'll have to fix that. If I jump in the air, he correctly shows the images for jumping in the air, and then he switches back to the idle animation when he's on the ground. So, ooh, we're so close. Look at that. It's great. So for this initial setup of changing our sprites and animations, there's only one thing left to do, right? We need to make sure that when the player is facing left, that he actually faces left. So let's come down to the very end after we've done all of these checks. Are we in the air? Are we on the ground? And we want to switch the direction of the image. If the player's left, they should face left. If they're right, they should face right. Well, we can make use yet again of this HSP value, and we're going to say if HSP is not equal to 0. Okay, that's again checking if they're moving, right? So in other words, if they're not standing still, then we're going to set the image scale equal to our favorite new friendly function sine HSP. Now what's happening here? Image scale is something you can do to scale an image. You can reduce the overall size of your picture. If you set image scale equal to 2, basically you'll get a sprite that's double in size from the usual sprite. But an interesting thing you can also do with image scale is you can put in a negative value and it will reverse the direction of your sprite. So if I say image scale equals -1, then our player sprite or our player S sprite or player R sprite will flip around and be facing toward the left. So by using this sign in conjunction with our horizontal speed, we can say if the player is moving to the right, which means horizontal speed will be positive, which will return a 1, our image scale will be equal to 1, so it will be facing right. If the player is moving to the left, meaning the horizontal speed is a negative value, that will give us a -1 for our sign, and we'll set the image scale equal to -1, which will cause the image to be facing to the left. And we only want to do that if the player is moving. That's why we're doing this if check here to see if they're actually moving left or right. So let's see what that looks like. Now I move to the right, he moves right. Oh no! Or Not quite yet. There's still one last piece. It's not quite working. Let's fix it and figure out why we're not getting this to work. Ah, you want to know why? Here where I've got image scale, we actually need to connect to the built-in properties. It's not image scale. In fact, I should know that, because if you look at all of the other built-in properties, they're all color-coded as green, and this one isn't. It's color-coded as a kind of purple color, which is the color that GameMaker is using when you're creating your own custom instance variable. So the actual built-in one is image X scale, and yes, there's a related image Y scale. So we can actually scale up and scale down an image on its X and Y coordinates. All right, so image X scale is going to be just focusing on the scale on the X axis, and then, but it will function the same way. It will still reverse its direction if we set it to be image X scale equals -1. Now when we come in here and push the right arrow, we move right, the left arrow, we move left. And we're up in the air, it works the same way, right? It's not checking whether we're on the ground in order to flip that image. It's just checking whether the horizontal speed is either positive or negative. If we jump straight up in the air, it just will stay with positive. Here I flip us to go this direction, so we're still flipped to that direction, and I jump and it stays with the image scale of -1. All right, that's it for this section. In the next section, what we will do is get our player to start being able to shoot.